in this video will be to demonstrate how it may be possible to make plotting simpler in an interactive Scala computing environment such as Ammonite, Scala CLI, any kind of Scala REPL. We're going to, for demonstration purposes, we're going to fire up an Ammonite 3 REPL, head to the Getting Started page of the documentation, pull in the library and a couple of the imports. We're now going to need a list of numbers which we can kind of make up as we wish. And with our list of numbers, we can now hopefully plot a bar chart. So that worked, which was nice. It may be we don't want a bar chart. Maybe we want something like a pie chart instead. And our list of numbers also has a plot pie chart method. So that's the elevator pitch. My name's Simon, and we're going to spend the rest of the video talking about how this worked and what the other things we may be able to do with it. Explain what's going on here is basically by having a quick poke around the code base. So we can see that we've imported this viz.extensions, and if we have a look in here, this is the inside the package viz.extensions, and it has this extension method, which is a kind of a Scala 3 construct, which adds a plot bar chart method to any kind of numeric iterable, which is a fairly kind of powerful concept. So anything that Scala can identify as a list, a sequence, or an iterable of numbers now has a plot bar chart method. We're going to, for now, ignore what appears to be the body of the method, and we can see that it returns a bar chart, but crucially, it returns a bar chart in the presence of this using or given plot target. So these are the two, well, there are three things we need to investigate, and we can also see that our bar chart takes a list of modifications effectively. And so these are the three, I guess, big concepts in the library and what we're going to talk about over the next kind of 10 minutes. It's actually really simple, and it will only take 5 or 10 minutes, I think, to explain almost everything that's going on here. I think our first area of investigation should be the plot target. This effectively sets out where the plot is going to appear. The trait, the implementation is, well, the signature is fairly simple, and it's the implementations that are of interest. The do nothing target does nothing, as you'd expect. It's fairly simple. The print untarget is the spec is essentially a string. That's the definition of the data visualization, and it's just going to print that specification to whatever terminal you're in. The desktop browser is the one that we saw in the elevator pitch. How it works is it basically naively prints an HTML template into a temporary file and then opens a browser pointing to that temporary file. Fairly simple. The next target that I think would be of interest is what I'm calling almond. The almond kernel works in a Jupyter computer, basically puts Scala in a Jupyter computing environment. It's important for me, I like that very much. And I guess you can see how it works. Like if we make some random set of changes to this particular visualization and rerun our code, we can see it's accepted these changes. Which is pretty useful. I guess I'm lying to you a little bit here because right now the Almond project, which is an amazing project, doesn't have an official release that supports Scala 3. I assume that it will as Scala 3 percolates through the ecosystem. I'm currently running my own version of that kernel off screen, but sooner or later I think that'll happen, and we're ready to support it when it does. The next target I think that would be of interest is what I'm calling the WebSocket target, which, as you might expect, spins up behind the scenes a little web server and basically listens for incoming changes or new plots. So I think that should now work. We can now do a bar chart. Starts up the web server and plots a bar chart. Maybe we now want to make some changes to our bar chart, and the nice part about the WebSockets target is that it doesn't change context when you press enter or when you refresh it. So you can evolve this fairly reasonably quickly. So maybe if we also wanted to make the chart larger, we could try something like that. And and we could also now, for example, remove one of the axes perhaps. There we go, and now our axis down the bottom is gone, just to prove it wasn't a fluke. We could maybe consider removing the y-axis instead. So that's the WebSocket target. The last three will only work if you have the Vega CLI package installed on your computer. But if you do have that, then you can also spit out PNG, PDF, and SVG files in a temporary directory. Going to go back now to our kind of entry point, this extension method, and have a look into our second concept, if you will, which is this bar chart case class, right? So I guess the question would be, where does that come from? And these are all, I guess, pre-canned plots, and these come from the Vega examples. So Vega has a very rich gallery of examples, all of which are available to us. So I mean, if we choose one at random, let's say this scatter plot, viz.vega.plots.scatter plot, and that should now have popped up here, which interestingly it didn't. Now what's going on here is that it's searching for data that effectively it can't find. The way that we could look into this is we're going to open this up in the Vega editor, right? And here we can see that actually this worked. So we would appear to have the right definition, but it doesn't work in our environment. And the reason here is this data URL. And so most of the Vega examples are wrong because my web server here doesn't have access to this data.cars.json file. So the way we could try and fix that is there's supposed to be a helpful method here, viz.utils.fix default data URL, and now it kind of well, it plots, right, which is what we want for right now. I'm going to make it bigger. I like big plots. So those were some Vega examples. Again, all of the Vega Lite examples are also ready for us to plot as well. They just have essentially Lite appended. So viz.vega.plots.grouped bar chart Lite. And let's go back to our thing. And so for whatever reason, that one worked. So there's a huge amount of effectively pre-canned plots that are essentially ready for you to use straight out of a Scala REPL. Well, obviously though, it's not helpful just to have pre-canned charts. I mean, no one wants to see the same bar chart repeatedly. So clearly we need to have a way to customize them. Inserting our own data, for example, would be a very common use case. Now you've kind of seen the, the hints at how that's going to work, and it's worth now talking a little bit about exactly what Vega is, because Vega is a grammar visualization, basically, and it works. This specification is entirely defined by this string, and this string is somewhat obviously a JSON object. So if we could find a good way to manipulate the JSON object here, then we can change the behavior of our chart. And that's the key insight, if you will, and forms what is our third concept. So if we come back to our start point, we can see that we're giving our charts well, one argument. And the one argument that we're giving our charts is this. I've given it a type. It appears so often. I've given it a type JSON mod, and it's a sequence of functions. It takes a ujson.value. So I happen to have chosen Liho's excellent Scala mu.json library, and we take a mu.json.value and basically perform a side effect on it. So our charts here and all the customization that you see me do earlier, all these are is essentially a list of side effects that we're going to apply to our base spec. Digging all the way down in the class hierarchy, at which point we'll have explored the entire library. Then we can discuss the design decisions, have a little bit of fun, and then it's the end. So we can see that all of our examples extend this from URL, and this from URL goes away and gets the specifications for each example out of the Vega repository, and that's how the examples are sucked into this code base. It doesn't actually own them, it takes them from the Vega repository, and I hope that makes it pretty robust actually to any change. Our from URL basically has this with base spec, so that claims we can get some base specification, and here we can see how the mods work. So basically we make a deep copy of that base spec, apply the mods to it, and then basically write it back out as a string. And that string is the definition of our visualization. And there's only one more class left, which is the spec itself. And it's this thing here that actually executes the show plot target, if you will. And so that's the entire class hierarchy. I mean, I went through it quickly, but it is simple. And if you read the code, you'll get it. So we can now go all the way back to the start again, and we can see our extension method. And we're finally in a position to talk about what it's doing in the middle. It's taking this list of numbers, and if we look at the spec here, we can see that this particular data entry for this particular Vega spec has category and amount, and that's what forms the label and then the number. What we're going to do is, for our incoming iterable of numerics, turn it into a UJSON object with a string and an amount, and then basically we overwrite the data values with our new array of JSON objects. And and that basically forms the boundaries in the library. So before these case classes, in theory, you can write type-safe code, if you will, and particularly if you give it an extension method. But at these case classes, it becomes untype-safe, and you're mutating the JSON objects behind the scenes, and effectively you're writing a Vega spec, or you're writing a pseudo Vega spec. So that's actually a little bit inconvenient, and we now want to talk about, does that make sense, and why that choice? And in my experience, actually, it works pretty well. I spend lots of time noodling around in the Vega editor to get the spec to where I want it, and then usually I end up just piping the data in through Scala. The library makes allowance for that by also having effectively custom plots. So this sunburst drag, for example, instead of taking the kind of the base spec from the Vega website, you could include it as a resource in your own code base, or submit a pull request to this one, and then you have your own chart. You effectively only need to extend the from resource class, and then you've got all of the same capabilities as the built-in stuff. To say that this practice of writing a function to change the JSON spec for each of your changes isn't super convenient. In practice, I found it's not too bad. So very often for me, those modifiers have ended up being reusable. So I can move different ones between different charts, or particularly if I'm producing a group of the same looking charts, you can reuse the same series of modifiers, which is quite nice. Now we need to talk about why it's done like this. So my experience of using Vega was that the way I worked with it was basically go to the example gallery, identify a plot that looked kind of similar to the plot that I wanted, and then basically poke it with the sharp stick until it did what I wanted. This library sort of formalizes that workflow by making them available as case classes, and then this kind of reusable modifier concept. And then secondly, allowing you to create your own base specification by basically saving them down as resources. Like anything, that would have a trade-off, and the trade-off is having to write those ujson.value to unit functions. It comes with, I think, three tub thumping benefits. And the first is that you start from success. So the normal strategy with a visualization library is you add some blocks like some bars, and then you go and you add an axis, and then you add another axis, and then you add a title. Well, here you start from something that already works and then evolve it towards what you want. But it's that starting from success that for me made life easier. The second one is that the library relies on Vega. So Vega's just Googleable. I mean, that's a massive benefit that I can't easily get by writing my own kind of DSL. And actually, it's a pretty Vega's exposed in a pretty raw manner. You're directly editing the spec. So the things that you can Google are directly relevant to what you want to achieve with your chart. And the third, I think, very big benefit of this approach is that there's very little maintenance. So the fact that the boundaries are at the examples that are exposed by Vega mean that I don't need to touch those examples. They're maintained by people far better at this than I am. And it makes the maintenance burden of this library manageable. Whereas the kind of the standard approach of trying to build everything up from scratch is just way too much. It certainly wouldn't be maintainable for me. So many of the design decisions here are deliberately targeted at reducing the on-running maintenance burden and turning it into something that's long run manageable. So for the final part of this video, in pursuit of some completely pointless knowledge, we'll see if we can use this library to visualize the distribution of tags on, well, let's say the Scala homepage to start with. So what I've done is defined a method which goes away and gets the page, gets the elements as a Scala collection group, map reduce them by tag count, and then plot the result. So, oops. And so there we have it, the distribution of tags on the Scala homepage. Divs and links, perhaps not surprisingly. Do the same thing maybe with somewhere else, the Guardian perhaps. And that's even more divs and links. So there we are, an example of how the library might be used. So that's it. Happy plotting. I hope you liked it, and if you did like it, leave a star, contribute. There's an infinite amount to do on such a thing. So good luck.